What's up, Mustangs? Miss Titus here, and today I'm here to teach you about exponential functions. We've talked about these briefly when we were categorizing functions into linear, quadratic, and exponential. So today we're going to talk about the parts of an exponential function and how to determine whether or not an exponential function shows growth or decay. Alright, so we always have three parts to an exponential function, a times b to the x. And we know it's exponential because our x is in the exponent. Alright, so A represents the initial amount. So whenever you're talking about growth or decay, you start out with an initial amount. This is pretty easy to remember because A starts with amount. Alright, B is going to be our growth or decay rate. Okay, so we can look at B, the base of our exponent, in order to tell what is happening. Is our population or is our, initial amount growing, or is it decaying over time? And time is going to be x. Alright, so go ahead and cross off these A's because it's supposed to say B. Alright, so when we look at B, we look at the base of our exponent. We're going to say, is it growth or is it decay? Well, if B is greater than 1, then it is a growth rate. If B is in between 0 and 1, then it is a decay rate. Okay? Now, when I say in between 0 and 1, that could mean a couple of things. It could mean a fraction whose value is less than 1, like 1/3. It could also mean a decimal, like 0.02. Okay? So these are all numbers that are in between 0 and 1. We're not going to look for a negative number. We're going to look for a number that is less than 1. Alright, so let's look at our example. We're going to say, look at our initial amount. We're going to determine if it's growth or decay. We're going to graph it, and then we're going to find some function values. Alright, so an example. We're given 2 times 2 to the x. So first I want to say, what is this, growth or decay? So above here I'm going to write y equals a times b to the x. Well, I know that a stands for my initial amount, b is my growth or decay rate. So if I look at b, b is 2. Up here I said that if b is greater than 1, then it is a growth rate. So here I'm going to have growth. Okay, and then our initial amount, A, is how much we started off with, so that's going to be 2. And then what is our growth or decay factor? So that's the numerical value of B, so that's going to be 2. Okay, we're going to graph over here, and then we're going to evaluate for x equals 4. So the easiest way to graph these is to use your calculator. So I'm going to go to y equals, and I'm going to enter in 2 times 2, and then I'm going to use the caret key right here to get an exponent to the power of x. And then I'm going to hit graph. So does this look like growth first of all? Just by graphing it I can say yes, because when I look from left to right, the graph is rising. Okay, so the next thing I want to do is go over here and go to my table and find a few values, because that will make it easier for me to plot. Okay, so I have the point -1, 1, so let's plot that point first. I have 0, 2, and then I have 1, 4, 2, 8, and then I'm kind of off the graph after that point. So let's go ahead and connect those dots and make them look like they do in our calculator. Alright, so our graph here is going to go from left to right. It's rising, so like I said, that's going to be a growth rate. And if we think about it, it makes sense. Our initial amount is 2, so when time is 0, when no time has passed, when nothing has grown or decayed, we are starting with 2, and that's our y-intercept right here, 0, 2. So we're going to evaluate for x equals 4. Now we know that we can do this a couple of different ways. I can actually do it like 2 times 2 to the power of 4. I can look at my graph. Well, it's not really on my graph. Or I can go to my calculator and check my table. I'm going to do it by hand first, and then I'm going to check it in the calculator. Alright, so 2 times 2 to the 4th. So remember our order of operations. First we have to simplify our exponents. So I'm going to go over here and I'm going to say what is 2 to the power of 4? And that's going to be 16, and then I'm going to multiply that by 2, and I end up with 32. So when x equals 4, y equals 32. So let's go to our table there and check. When x equals 4, y equals 32. So we know we're right. Alright, so those are the parts of an exponential function: the initial amount, the growth or decay factor, and the exponent, which represents time. If you have any questions, make sure you write them down in your form and let your teacher know when you get to class tomorrow. And as always, staying strong.